Alright, so we're moving on here. We're continuing on and still 9.1. We're still on page 610 and we're just working on a different type of problem. The problem in this case is going to be to rewrite the expression using only rational exponents. Okay. For this, we're going to be using the definition of rational exponents, which is basically that whenever you have a rational exponent, it's the same as if it would be in a radical, right? So the 1 over n power is the same as the n root. Okay, and sometimes you'll have it combined, kind of how we did in the last problem that we just worked out. And I remember I told you in that problem that you can either turn it like this or like this, depending on how you want to work it out. Okay, so let's get right to it. Let's start with number 21 from page 610. And this one's pretty simple because you have the same base, okay, and they are both already in rational exponent form. So all you have to do is remember your exponent rules. And remember that whenever you have multiplication, okay, in this case in multiplication, remember that means that you're going to add the little numbers. Okay, in this case we're going to add, and let's go ahead and use a different one. We're going to add this plus that. Okay, and we're going to go ahead and write it out. Basically, you're going to have 3 over 4 plus negative 1 over 6. So that's basically just subtraction. Now we know that we cannot add these two together because they don't have a common denominator. So what we're going to do is we're going to basically turn this into a problem that has a common denominator. Let's go ahead and get a common denominator between 4 and 6. The smallest one is going to be 12. So just go ahead and make it over 12. What do you do to 4 to make it 12? You're going to multiply by 3. Whatever you do to the bottom, you have to do to the top. So that's going to give you 9 over 12. Plus a negative, that's just going to be minus, right? So then we're going to go ahead and turn this one, 6 becomes 12 by multiplying it by 2. Whatever you do to the bottom, you have to do to the top. So this is going to go ahead and give you 2. So 9 over 12 minus 2 over 12 is going to go ahead and give you a 7 over 12. Now, remember that this is multiplication of these two variables. Both of these variables have a power that's like this. This cannot be your final answer, okay? Remember that your final answer is still going to have the variable in it. So your final answer will be x to the 7 over 12 power. So that's that one. That one's pretty simple, not too difficult. Let's move on to this one. And for this one, we are going to use this property right here, the definition. Now, to be able to work this one out, first we have to realize that inside the radical, you still have a multiplication of these two values. Keep in mind, though, that these two values do have different bases. Okay, so at the very end, we're not going to be able to combine them into one answer. It's still going to be multiplication. We're trying to simplify. Okay, we're trying to simplify. So basically, what we're going to do is we're just going to rewrite this into rational exponents by using this property right here. Basically, what we're saying here is that if you have something like this, or in this case, it looks a little bit more like this, we can turn it into this. Whatever the power is in the numerator. Whatever the root is in the denominator. Okay, so we're going to go ahead and I'm just going to circle the powers in green, and I'm going to circle the root in blue, and I'm going to write them like that when we rewrite this. So here we're going to start with the m, and remember that m is to the third power, so we're going to have to the third power over, and then what do you think that root is going to be? It's just going to be 4. Okay, it's going to be 4. So m to the 3/4 power. And remember that this is a multiplication problem, so we are just going to go ahead and multiply that n. And then the n is basically the same exact thing. It has a power of 8, and it has a root of 4. Okay, now you may think to yourself, okay, perfect. So now we just use our exponent rules. Video cut off, but we're going to go ahead and just pick up right where we left off. So I finished off telling you guys that we got to this point right here. Okay, forget about the answer that I wrote here. I kept writing even though the video cut off, and I finished the whole thing, and then I realized it was frozen. But in this case, we finished off here where we had m to the 3 over 4 times n to the 8 over 4. And what I was trying to get at is that when we see this, we would think to ourselves, oh, hey, let's just use our exponent rules and let's go ahead and combine these two by adding the little numbers. Remember that when you multiply variables with exponents, you're adding the little numbers. However, we cannot do that in this case because they are different bases. Since m and n are a different base, we cannot merge those two together. Now, since we can't merge them, we're just going to have each one of them as a variable. 3 over 4 is simplified, but here 8 over 4 simplifies into 2, and that's how we got that final answer there. Alright, so we're going to move on to the last type of question that I want you guys to know, but actually it's not the last type of question. I do want you guys to know one other type of question in your books. If you look in your books on page 610, numbers 37 through 40, I want you guys to know how to do those questions, but those are pretty simple. It says evaluate the functions as indicated if possible and simplify. You basically just plug in the values for x and then go ahead and simplify your answer, okay? But this question right here, describe the domain of the functions. Fxn just means function, okay? So basically, I want you guys to tell me the domain. Now, what is the domain? Remember that the domain is basically all the possible x values that you can have. Now, some equations will have restrictions on the domain, but some equations won't. When it comes to radical equations, you do have some restrictions. What is the only restriction really that we know is that whenever you have a square root, a fourth root, a sixth root, basically an even root, we know that we cannot have a negative value in inside the radical, okay? So we can't have a negative value inside the radical. We talked about that in the previous problem. So how do we know the domain of this function? In this case, since it's a square root, basically the domain of any radical function, if your n is even, then basically the non-negative real numbers inside of here, the x value, whatever is inside the radical, here is x. X can be non-negative real numbers, so all the way up to 0. Basically, what you're saying is that what is inside has to be greater than or equal to 0, okay? It just cannot be negative. It can't be less than 0. It can be 0, okay? So how do we find the domain of the function? Very, very simple. You're just going to go ahead and take whatever you have, what's inside, and you're going to plug it into that. So we're going to rewrite that as 9 minus 2x is greater than or equal to 0. Okay, and when we do that, we can go ahead and solve. We know how to solve equations like this, right? We treat it as if it were an equal sign, but there's just a couple little tweaks that we need to make every now and then just in case. Okay, we want to get the x by itself, so we're going to subtract 9 from both sides. We end up with negative 2x is greater than or equal to negative 9. Then we divide by negative 2, divide by negative 2. We end up with x, and remember, when you multiply or divide by a negative, you have to flip the sign, okay? Because you multiplied or divided by a negative, okay? And that's very, very important that you do that. You go ahead and you put this here. Now these, the negatives will cancel out, and then you end up with just 9 over 2, okay? So you have that 9 over 2. Now x is going to be less than or equal to 9 over 2. This is basically a domain, but remember that we always want to write it as interval notation. Now, interval notation, it helps out if we go ahead and we make a little number line with the 0 in the middle, whereas 9 over 2 is going to be something like 4.5, I believe. So let's just go ahead and write 4.5 right here, and then we have 4.5. Now we know that x is less than or equal to, in this case, x is going to be less than or equal to, so we know that x, since it's equal to, it's going to be one of these, and it's going to go that way. That means that x can be anything from 4.5 to this direction. Remember though that we write using parentheses and brackets, so we're actually going to rewrite that as this. And that helps us visualize when we write our interval notation. We know that x can go all the way this way, which means that it can go to negative infinity. So x is going to go from negative infinity all the way up to 4.5, or 9 over 2. And we're going to close that with a bracket because of the fact that it is equal to. Okay, now let's move on to the next one. This one's a little bit different, but still following the same domain of radical function rules. If it's odd, if your n is odd, which in this case it is, your domain is always just going to be all real numbers. Just like the previous problems that we saw, we know that inside this radical can be anything. And anything because this is odd. Okay? So what's your answer going to be? It's all real numbers, but we write that as negative. Sorry about that. Let's rewrite it in blue. We write it as negative infinity to positive infinity. And that's your final answer here, and that's your final answer here. And that's the end of 9.1.